For this video, we're going to go through the logarithm rules, the ones that correspond to the exponent rules we've known from previous courses. So the first one is the product rule. Now recall from your reading, that rule is log base b of m times n is equal to log base b of m plus log base b of n. If we have multiplication inside a logarithm, we can make it the sum of two logs. And vice versa, we can always condense. We have the sum of two logs. As long as they have the same base, we can turn it into a single logarithm. So here we look for any multiplication. And the way that I would normally expect someone to start this off is to say, oh, well, we're taking 27x and multiplying it by y. So we should get log base 3 of 27x plus log base 3 of y. And that's not wrong, but it's not complete. Because let's look at this one. 27x, that means 27 times x, which means we've got more multiplication. So we can expand this farther. So we have log base 3 of 27 plus log base 3 of x plus log base 3 of y. And we are not yet done. As long as we're expanding, let's simplify as well, and we can evaluate log base 3 of 27. That's a beautiful number. 3 raised to what power is 27? You're right, it is 3. So we can rewrite that as 3 plus log base 3 of x plus log base 3 of y. And that's a run at the product property. So let's play with quotient. Recall, log base b of m over n. Well, if multiplication went to addition, then yes, as we guessed, division will go to subtraction. And so here we do our subtraction. We're taking x and dividing it by 10y. So we should have log of x. Oh, I don't have a base. What's that mean? That's right, base 10. So we have log base 10 of x minus log base 10 of 10y. Uh-oh, but 10y, that's multiplication, so we can go farther. We can use the product rule. We aren't going to change this first one. Log of x minus, but if we're expanding this, this is what we are expanding. Right now it is all grouped together as one thing, so we still need to leave it grouped. So we have log of 10 minus plus log of y, because that's multiplication. Multiplication becomes addition. I said minus because I did the next step already. I usually don't bother to think about these parentheses. I recognize these were both on the bottom, so we must have subtracted both of them. But here I put those parentheses in because everything inside the parentheses is exactly what we saw here. But now we want to distribute that negative through. So we have log of x minus log of 10. But wait, we know log of 10. Log base 10 of 10. That means 10 raised to what power is 10? Well, that's just 1. Minus log of y by distributing that negative through. And so we end up with this. Power property. Recall, log base b of m raised to the p. Now remember, this has to be the inside raised to a power. It can't be the whole logarithm raised to a power. This is the same thing as p times log base b of m. So this one's straightforward. I've got x to the fifth. I'm taking the common log of that. And so we can take the power and bring it out front. So we'll get 5 log base 10 of x. So let's put these all together. And we will expand this one. Now, last time I had two things together. That was up here in the quotient one. I did it one step at a time, but notice where we ended up. Both items that had been on the bottom ended up being subtraction, whereas the item on the top ended up being addition. And so we can take that shortcut, but before we take that shortcut, let's verify it works here. So I've got division. I have 3 items inside, but they're all being raised to different powers, so I have to wait on the power rule. So we'll start with that division, because the multiplication also is sort of inside the division. So we'll start by taking natural log of the top, x squared times y cubed. Pardon me. And we subtract natural log of the bottom, square root of z plus 1. But here there's still multiplication, so we can expand it farther. That's the natural log of x squared plus the natural log of y cubed minus the natural log of the square root of z plus 1. Now you're probably going to ask, why didn't I put parentheses around this? Well, I could have. I could have put parentheses or brackets around this to show that it all came from this one. But what's out front? A positive 1. So when I distribute it through, turns out those brackets didn't matter. Now I can play with the power property. That, my handwriting's bad, but we can see up here it was x squared, so I'm raising the entire inside to the second power, which means we have 2 times the natural log of x. That's y cubed, entire inside is raised to the third power, so that's 3 times the natural log of y. Oh, square root, what power is that? Well, remember, that is the same as saying z plus 1 raised to the 1/2 power. So this is 1/2 times the natural log of z plus 1. Now it's really, really tempting to say z plus 1. That's addition. I can turn it into multiplication, right? No, it's only if we have addition outside. Addition of logarithms can turn into multiplication. Addition inside, we're stuck, which means this is as far as we can expand that. Well, let's try condensing. I have 1/3 log base 4 of z minus 3 log base 4 of x plus 2/5 log base 4 of y. Now, first of all, I cannot use the quotient rule right here because the coefficients are different. That quotient rule, if we go back up and look at it, both had coefficients of 1. As long as both coefficients are 1, I can use the quotient rule. If they aren't, I have to do something else. Oh, but we've got a beautiful little power rule, and yes, it goes backwards. P times log base b of m is equal to log base b of m raised to the p. And so we'll do that with each one. 1/3 log base 4 of z is the same thing as log base 4 of z to the 1/3. Ooh, but raised to the 1/3 is also the cube root. So I'm going to write it like that. 3 log base 4 of x is the same thing as log base 4 of x cubed. 2/5 log base 4 of y. It's the same thing as log base 4 of y to the 2/5. And yes, we can fix that a little bit more, and we will in the next step. But I'm going to use the quotient rule now. So notice one thing on the quotient rule. I am not going to write log base 4 of the cube root of z divided by log base 4 of x cubed. The logarithms are not being divided. It is only the inside that's being divided. So we have log base 4 of the cube root of z over x cubed. Plus, now let's play with this power. 5 on the bottom means we're doing a 5th root. The 2 up top means we're squaring it. Or another way to look at it, y to the 2/5 is the same thing as y squared to the 1/5. If you remember your exponent rules, you multiply the exponents to condense them. So this is the same thing as log base 4 of the 5th root of y squared. And now we want the product rule. So we'll multiply these insides. Again, I'm never going to multiply the logarithms. I am adding the logarithms. Multiplication and addition are not the same thing. But I can multiply their insides. So we have log base 4 of the cube root of z over x cubed times the 5th root of y squared. Well, that looks a little ugly like that, so we'll say it's equal to, let's actually do that multiplication. Log base 4 of the cube root of z times the 5th root of y squared over x cubed. And that is fully condensed. Now let's look back at the previous two for that little shortcut. I claim we can skip this step here. I claim we can skip this step. Anything up top is going to give me a positive logarithm. Anything on the bottom is going to give me a negative logarithm. So I can jump straight to writing, when I see this, I can jump straight to writing natural log of x squared plus the natural log of y cubed minus the natural log of the square root of z plus 1. Similarly up here, I can't jump straight from this step because the coefficients are different. I need to write this out. But then from this step, I can jump straight to the end. This is a positive logarithm, so the cube root of z is going to go up top. This is a negative logarithm, negative coefficient. So x cubed will go on the bottom. This logarithm has a positive coefficient. It's a positive logarithm. So y, well, really the 5th root of y squared goes up top. And we can go ahead and make that jump immediately. Good luck with this week's work.